Alrighty, going into 12.3 two-way tables and probability. We are going to create tables and basically find the probability that of these different events. Maybe we decide that something is more probable, or we want to go with this trend because it has a higher probability based off of the different data that's been taken, and then looking at tables and determining those different things. So two-way table, a frequency table that displays data belonging to two different categories. In this situation, we have people that took a survey probably, and they told us if they like skateboards or don't like skateboards, and then they also asked if they like snowmobiles and not. And so this is the combination of people that like skateboards and snowmobiles, right? This would be the combination of people that like snowmobiles, but they don't really like skateboards. This is the total number of people that like snowmobiles, right? If you're following the track of this table. And then likewise of these other ones, these are the ones that don't like snowmobiles. These are the ones that don't like skateboards, total amount of people that like skateboards. This in the bottom right will always have the total number of people that took the survey, or the total number of however many trials you had, right? For each entry in the table, it's called a joint frequency, and the sum of each row and column is called the marginal frequency. And we'll talk a little bit more about what those look like in another page. Create and interpret two-way table. You randomly survey students about whether they are in favor of planting a community garden at school. 96 boys, okay, so it's probably going to be a boys-girls thing, surveyed. So this is a total number. 61 are in favor. Okay, so it looks like we're going to be talking about boys and girls that that favor something or don't favor something, just based on what I just read. I could be wrong, but typically you can kind of find out what it's going to look like, but even before you get going. 88 girls surveyed. Okay, here's our other total that we'll want. 17 are against. Okay, so favor, not favor. Organize the results in two-way table. Discuss the marginal frequencies. Okay, so we kind of already determined what we're looking at. We're looking at boys and girls, and then favor, not in favor. And you're just going to put that in your columns here. Does it truly matter which categories go in which? Not really. The only thing that you're going to just make sure you take note of is, well, one, keep them organized. Don't put favor and then boys, right? That'd be kind of silly. Favor, I can't really write here. And then I'll just write not. Okay. And so we want to categorize all these things so that we can properly have some good results. Then someone can just kind of look at our chart and say, hey, well, that's what that is. That's what that means. I don't know, whatever you want to write up here. Voting, favor, not in favor. I'll put voting. I don't know. I'm just making it up. For the garden, you can probably be as specific as you want. Obviously, the more specific, the better. I just don't have room. And then this is like the gender, I guess, however you want to say that. All right. All right, so we have a couple of pieces of information. We have 96 boys, okay, so we can put that in our total. We have 88 girls, so let's put that there. Great. We said that 61 boys are in favor, so 61 is going to go here. How are you going to find the one that's not? Well, you're going to subtract 96 from 61, then find out how many people didn't, how many boys did not or not in favor. Put that in your calculator, 96 minus 61, you get 35. Great. Okay, same thing with the girls. 17 are against, so I'm going to put that in the not category there. And then same thing, 88 minus 17 to find out how many are in favor here. I got 71. Awesome. Sorry if that looks like a Z. 71, right? And then what you're going to do to find out how many were in favor, right? You're going to add those two up, right? So 2 right there. 132. Great. Same thing with not. How many are not in favor? So this is where the information comes pretty helpful. This is 52. Nice. And then it doesn't matter either way you slice it, whether you go this way or you go this way, you will find the totals. Don't crisscross these, right? That's silly. You want to go down the list, right? Add up how many boys and girls that voted or how many were in favor or not in favor, and you'll find the total, and they'll be the same exact amount. I got 184. 96 plus 88 is 184, and 132 plus 52 is also 184. So either way you slice it, you can do the same thing. Great. We have a nice chart here, and we can use this information to help us with pinpointing different situations, like how many boys were in favor of the, planting the community garden in school. Oh, 61 boys were in favor. But the question is going to be later, what's the probability that you are a boy and you are in favor of the voting? That's what we're going to find out next. Okay, joint relative frequency and marginal relative frequency. Both are fairly similar in the way you find them, except the marginal is going to be on the outside and the joint is going to be on the inside. On the inside. All right. So let's see. Joint is find by taking each of the entry in a two-way table and dividing by the total number of observations. The marginal is the same thing. I knew it was on the outside because it says sum. That's when we added the stuff together in a two-way table, dividing by the total number again of observation. So we're looking at whatever this number was on the other page, and we're going to divide each of these numbers by the total, the 184 that we found in the back, right? 184 down here. So let's take a peek. We saw that there were 61 boys and 184 total votes, right? So what you're going to do is you're going to divide those numbers. This is the joint, right? The inside white little boxes are going to be the joint relative frequencies. Okay, and when you divide 61 by 184, you're going to get about point back. There we go. 0.332. All right. And for here, right, we had 35, and we're still going to divide by 184. Basically, at each one of these, you're just going to divide that number by 184 and get a decimal, or really it's a percentage, right? So this is I got 19. I'll keep writing them outside so you can see. 71 over 184 for the bottom right, bottom left. And then bottom right should be 17 divided by 184. I got 0.092 and then 0.380. Oh gosh, 386. Great. Okay, and you can obviously change all these to percents, right? We'll leave those there for now. If you want to relabel these things, that's fine. I'm not going to take the time to do that just for the sake of the time for the video. But yeah, you could do those. These are the same thing. Boy, I'll do a quick one. Boys. Oh no, that's not right. Let's see if I can fix that real quick. Mm-hmm. And so for the marginal on the gray column, what you're going to do is you're going to add those decimals up. Say FN and then BG. You're going to add these up and then find the total amount in the, you could say percentage or the decimal form. Now, what you don't, especially if you're going online and punching in answers, they're going to want the exact number. So what you're going to need to do on the calculator is you're going to have to do 61 divided by 184 in parentheses plus 35 divided by 184, and then click enter. That way you have the exact amount, not these rounded forms over here. So when I did that, I got, oh gosh, what did I do? I think I got 5.522. I might need to do that again. That seems a little off. For down here, you actually get a clean 0.4. Doesn't happen, well, it might happen more often than I might think originally. Let's see. Just want to make sure I'm giving you the right stuff here. 35 over 184. Yeah, I got about that. I'm gonna double check the bottom there. 71 divided by 184. Plus parentheses 17 divided by 184. Oh yeah, that's not right. Sorry. I don't know why I got 0.4 there for whatever reason. It didn't redo that one. Let's see. Should get, I thought something was a little fishy there. You do not get a clean 0.4. You get a 0.478. And so what will happen is when you add these two things up, you should get this will always be a clean one because you have a 100% of boys and girls voting, right? So that should make sense. You do the same thing for down here. I got 0.717. And over here I got 0.283-ish, right? You add these together, you should get 1 as well. So if you're looking at the information, right, you can say that this right here is the percentage of people that were in favor, right? You say percent of people, right? Because that includes boys and girls, everybody that voted, people in favor, right? And so then maybe over here, you could say, okay, 52.2% of people, 52.2% of boys voted. Of the voters were boys that voted. 52.2% of people were boys that voted. That would be what you'd kind of say over on this right-hand column. So you can decipher the different information based off of what we found there. Yeah, and like I said, this gray, not bad. This gray stuff over yonder is going to be the gray boxes are going to be the marginal, and the white on the inside are going to be the joint relative frequencies. All right, there we go. Conditional relative frequency, finding conditional probabilities using relative frequencies. And really, this is just identifying. They give you the table already, and now you got to identify what they're asking for based off of the information they give you. This is kind of usually what they put on like a standardized test, right? You got to find the information located in the table. Then the conditional probability is satellite TV provider surveys customers in 3 cities. The survey asks whether they would recommend TV provider to a friend. The results given as joint relative frequencies are shown in the two-way table. What is the probability that a randomly selected customer who is located in Glendale will recommend the provider? Okay, so these are recommend. Oh yeah, I want to recommend it. And this is not recommend it. And then these are locations. So Glendale, they said they would recommend it. 0.29, so that means 29%, right? So 29%. That's the answer. Great. That's, it looks like a 4, doesn't it? Yeah, that's about it. So these are pretty straightforward. What's the probability that a randomly selected customer who will not recommend the provider, so not, will be located in Long Beach, right? Right here. So looks like it's going to be 4%, right? Not 40, right? That'd be another decimal place over, 4%. What was the probability that a randomly selected customer was located in Santa Monica will not recommend the provider? 30%. Done. Use data to find and compare the probabilities. So this is when it all comes together here. So get ready, put your socks on. Let's get this underway. Jogger wants to burn a certain number of calories during his workout. He maps out 3 possible jogging routes. Before each workout, he randomly selects a route. Then determines the number of calories he burns, whether he reaches his goal. The table shows his findings. So if you notice, it doesn't really tell you a calorie count. Sometimes that's what the problem is asking for, about how many calories am I burning? This is actually just telling us if he reached his goal. So we're not even worried about calories. We're worried about if he reaches his goal. How many times did he reach his goal? In this time, he reached it 11 times. In this time, right? 5, 10, 11, right? He reached it 11 times. In this time, he reached it 12 times. He didn't reach it 6 times here. He did not reach it 4 times here. And he did not reach it 6 times here. Okay, so that's another way you can kind of rewrite that. Now, it's going to ask us to find a two-way table for joint and relative frequencies. So it already kind of provides you with most of the normal table here, but it doesn't give you these totals, which we're going to need going forward here, especially if we're going to use the marginal frequency. We're going to need the total amount. So let's do it. How many times on route A did he run, right? This would be 17, right? 11 plus 6, 17. So he ran route A 17 times. All right, same thing here. Looks like he ran route B 15 times. And then here, route C, looks like he ran it, you guessed it, 18 times. So if we're going to find the total, right, we're going to, now, could you have done it the same way, going down this way and then down this way and then adding them over here? Yeah, totally. You could have done the same thing. I got that he ran 50 times. If you did it the bottom way, let's see what I got. Just double check. Oh, I didn't even do it. 11, 12, 22, 34 plus 6 plus 4 plus 6 is 16. 34 plus 16 is also 50. Yes, so he ran a total of 50 times. Right? So that's going to be times. Yeah, times. That's going to be important in making our new frequency table, right? And that'll help us to answer this last question: which route should he use if he wants to burn calories at a more success rate, right? So we'll look at this number here, whatever that's going to be, right? We need to find those percentages. We need to find those kinds of things. So what I'm going to do is make a table. A, B, C. So similar to what that chart, almost identical. I'm going to put Y and N for reached and not reached. You can label that however you want. I just don't have a lot of room to work with over here. All right. And so we're not going to need these numbers, really. You could find them, right? But what it wants is to compare the routes. Which route should he use? So I know that I'm going to compare this route to this route to this route to see which route is best for this man, this jogger man. You can give him a name if you want. But yeah, so we need to find out which he has the most success. Or sorry. No, that's not right. That's just the percent of how many times he runs. We want to find this actually. That's not right. We don't want to find this. We want to find this would give us the amount of times that he ran those routes. Ran percentage, right? How many times did he run at route A? How many times did he run at route B? How many times did he run at route C? So we don't even need to find this column either, which is kind of nice, especially because it doesn't tell us to find the marginal up here. It doesn't even say that. It just says find the joint. So that's another cue. My mistake. Sorry to misled you at the beginning there. All right. Well, looks like if we I kind of told you the answer. We need to find these. See which one he had most success in. So 11. Oh, okay. I'm going to use a different color. 11 over 50 is that one. 11 over 50 is that one. And 12 over 50 is that one. This seems too easy. What? Well, it does say to make a two-way table of joint relative frequency. So we do need to finish this to properly do A. But we don't need to do this because it didn't say find the marginal. Yeah, you can do it if you want. I did out of being ready's sake. But all right, well, this is 6 out of 50, right? I'm pulling these numbers from over here, right? 4 out of 50. What was that? 6 out of 50. Great. Okay. And then you just need to divide all those numbers, right? And if you're slick, you see it's out of 50. The fastest way to do it is really just double the numerator because that gets you to 100%, right? If you want to type in the calculator, it's fine. But I know from grading, right? I do a lot of grading. This is just 0.22 because I doubled the numerator because I know it's out of 100. This is 0.12. This is 0.8. Sorry, not 0.8. That would be 80%. So 0.08, right? If you're doing it that way. This is 0.12. Sorry, I'll write this in red now because it's kind of getting hard to see. This is also 0.22, and this is going to be 0.24. Some people at the very beginning said, oh, I know what's the best route to take. Find and calculate the conditional probabilities of the joggers reaching his goal for each route. Which route is the best? Should he use? So we just did that, right? It's 22% for route A. It's 22% for route B. And it's 24% for route C. So you'd say that C is the best route. Cool. If you want to finish this, I'll just tell you, right? This is going to be a 32% because you add these up. I'm sure you're going to have to do that in the homework at some point, right? This is just adding these up over here. And same thing going down, right? You're just adding them up to find those. And once you get to the very end, right, those percentages should add up to 1 or 100%, right? Blah, 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 blah. 30%, 36%, 68%. Sometimes they'll ask you that. 68% of the time he reached his goal. That would be the most interesting of all of it, right? How many times did he reach his goal? 68% of the time. This is 32. And it all adds to 1 or 100. Great. All right, that is the two-way table. Be able to do those things. Let me know if you have questions. Good job. Good luck.